Hey there, Python trainer Ruben Lerner here, and today I want to talk to you about two pandas methods that I found not a lot of people know about, and those are nlargest and nsmallest. And you might be able to guess what these methods will do based on their names, and you probably would not be wrong, but I want to go into a little more depth and discuss when we would use them, when we would not use them, and how they can work both on series and data frames. So I'm going to say import numpy as np, and I'm going to say import pandas as pd, from pandas import here in a data frame. And now I have like all the shortcuts available that I want. Now I'm going to say np random seed 0, and that means that if you play along at home, you will get exactly the same results as I do. And now I'm going to create a series. I'm going to say s equals a series of np random randint from 0 to 1000, 10, meaning I want 10 random integers between 0 and 1000, and we'll say the index is equal to list of a, b, c, d, e, f, g, h, i, j. Should be good, and sure enough we have our numbers here. Fantastic. So what are the three largest numbers in S? Well, that's pretty easy, right? I can say S sort values. That's going to sort them. And what's that going to give me? A new series back. It does not modify the original series. Sort values gives me back a new series from lowest to highest. And we can see it's sorted by the values. There's also, of course, a sort index method, but we're not using it here because we want to, well, sort by the values. And then I can say dot tail 3. Now, tail usually gives us 5 values, but if I say tail of 3, then I'll get 3 values, and here we go. I have the 3 largest values in S. Fantastic. I can turn this around, by the way. I can say S sort values, ascending equals false, dot head 3, and then sure enough, I get, here we go. Now, you can see that I'm getting now the highest to lowest. Suppose the lowest to highest, but it doesn't matter that much. At the end of the day, if I want the 3 largest values, this is what I'm going to do, and this is how I'm going to get them. What if I want the 3, let's even say 4 smallest values? Well, then I'll just sort of turn around what I did. I say s sort values, and then I say dot tail, or I guess head of 4, and that's going to give me from the smallest to the, I guess, third smallest, fourth smallest, and then, you know, we can turn that around to, although I don't know why you want to, s sort values of ascending equals false, and we say dot tail 4. So this works great, but that's not why we're here today. We're here today to see a shorter way to do it, and I can say s nlargest 3, and this will give me the 3 largest values, or I can say s nsmallest 4, and that'll give me the 4 smallest values. And notice that it's always going to rank them in nlargest from largest to smallest, and then smallest from smallest to largest. So we're always going to get like the smallest and the largest at the top, then the next smallest or largest, next smallest or largest, next smallest or largest, and so on and so forth. If we don't pass anything, if I say s nlargest, I just get the 5, just as if I had done head or tail. Okay, so that actually works pretty well. What about in a data frame? What if I say df equals data frame of np, let's see if we do it, np random seed 0 again. So we'll reset everything, random randint, and I'll say from 0 to 1000. Now I'm going to say, let's say 6 by 6. All right, and then I'm going to say here the index should be list of a, b, c, d, e, f, and the columns are going to be list of v, w, x, y, z. No, I still need you in there. I always need you, dear watcher, dear viewer. Okay. And now, corny jokes aside, although impossible to work without them if you're working with me, we now have 6 rows and 6 columns. So now I can say df.n largest of 3. What the heck is it going to do? It's going to say you can't do that. Because when I say I want the 3 largest values, what am I talking about? What does it mean? If we go down here to the error, it says, no, you're missing the required positional argument columns. In other words, which column do we want to base this on? So I'm going to say here df nlargest 3 columns equals x. And so now what are we getting? We are getting the 3 rows associated with the 3 largest values of x. So if the largest values of x are 976, 723, 551, we're getting the row along associated with 976, then the row associated with 723, and then the row associated with 551. Now, what if we have two values that are the same. So I'm going to do that. I'm going to say df lock of, and we're going to say here b and x equals 551. So now if I say, let's take a look at df, now x has 551 twice in there. So what if I say now df nlargest 3 columns equals x? Well, that's okay. 551 is a tie, and so it's going to be here. Now, as a general rule in Python, wherever you can give one thing as a string, like a column or a row, but typically a column, you can pass more than one thing as a list. So can I say here, I want to sort first by x and then by y? Yes, I can. So here I'm saying nlargest, first by x and then by y. Now, you'll be saying, well, that has not made any difference because 551 and 277, that's larger, and 551 and 87, that's smaller, right? So that's going to be in the same order. But what if I say by x and then w? And now you'll see that they've swapped their order. Now we have 551 and 551 and x because there's no way to deal with it otherwise. But we have 486 and 9 here because we're sorting from largest to smallest according to column w. Pretty snazzy, right? I think so. Now, this does raise a question of what's faster, especially if we're dealing with a series. So if I go back to my S and I say S nlargest of 3, it seems like it runs pretty fast, right? How long does it really run? So if I now say percent time it, so we're now going to run this a whole lot of times, and we're going to see how long it takes to do nlargest. That's 319 microseconds there. What if instead of that, I were to say S of sort values, and then I want to say tail of 3. Is that going to take less time or more time? It's going to run it a whole lot of times. That's going to tell us on average how well it did. And look, it takes 75 microseconds. In other words, it takes a lot less time for us to run sort values and tail than it does for nlargest. So why, if it's so much slower, am I showing you nlargest and nsmallest? Because if you have a small-ish data set, I find it often easier to read, easier to work with and understand. And the snazzy stuff we can do with the columns, yes, you can do it in another way. For example, by sorting the values by different columns. But I just find this a little more readable. Again, once your data set begins to get large enough that it'll make a difference, you probably should switch then to sorting. And it's always useful to do these sorts of tests because different data will sometimes work out in different ways. Anyway, I hope that you now see how nlargest and nsmallest work, how you can use them with series and data frames, and how they compare speed-wise with sorting and header tail. If you have more questions or comments or topics you want me to address, please let me know. Leave me comments, leave me feedback. I can't wait to see them. I will be back soon with more about Python and Pandas.